everyone, let's have a small discussion, that is what is called acid, what is called base. To define what is acid and what is base, there are some theories have been described. Those are nothing but Arrhenius theory, Bronsted-Lowry theory and Lewis concept, right? So these three theories already they have defined what is acid and what is base to a certain level. But actually what exactly the theory is followed, that is nowhere it is restricted or nowhere it is completely defined. But we know that what is acid means that having the pH from 1 to 6, and what is base means which is having the pH from above neutral, that is 7 to 14. Okay. So which is showing the pH values in these ranges, we are going to differentiate them acid as well as base. But exactly how we can define any salt or any type of the complexing agent as salt or base? So we need the help of some of the solvents for this, because some of the solutions only we can take the measurement of the pH by using the pH meter or potentiometer or whatever it is. But without that, how we can differentiate which compound is acidic in nature and which compound is basic in nature? In that case, you need to see the theories involved in describing these acids and bases. Okay. So let us see what is acid and what is base. If in this case you are going to know about the three theories involved. So first of all, let us have the Arrhenius concept. So Arrhenius has defined this concept in the 1887. So in this theory, what he has told that according to this concept, acids are the substances that dissociates in the aqueous medium. We need the help of the aqueous solution here to give the H plus ions. Okay. So and bases are the substances that produce the OH minus ions in the aqueous medium. So for this Arrhenius theory, they have given the examples like ionization of an acid which is going to take place in presence of the water. If you take the example of hydrochloric acid, in presence of the aqueous medium H2O, it is going to ionize into H plus ions as well as Cl minus ions. So according to the definition, that dissociates into the aqueous medium to give the H plus ions. That means what is acid according to Arrhenius theory, which donates the H plus ions, is called as acid. And coming to the ionization of the base, that means if you take the example of sodium hydroxide, it is going to give you that sodium ions as well as OH minus ions. So according to the Arrhenius concept, what is base? Bases are the substances that produce the OH minus ions. So this example is going to satisfy the Arrhenius concept. And according to that concept, acid is also going to give you the H plus ions. But the exceptional case here is in the aqueous medium only. That's why this concept is going to have some drawbacks. So drawbacks of the Arrhenius concept, if you are going to see, applicable only to the aqueous solutions only. In presence of the aqueous medium only, these are going to give the ionization of the molecules, and it fails to explain the acidic nature of the substance like CO2 and SO2. So CO2 and SO2, sulfur dioxide, so carbon dioxide, these are also acidic in nature. Actually, they do not produce the H plus ions according to the Arrhenius concept. Okay. And bases like sodium carbonate and ammonia, these are also not going to give the OH minus ion, but they are going to act as bases. So Arrhenius theory is unable to explain the some of the reasons behind it. So it is applicable only in case of the aqueous solutions only. And in this 1887, so this concept has been followed, but due to the limitations afterwards, they have seen some of the other concept, that is Bronsted-Lowry concept. Okay. So in this Bronsted-Lowry concept, if you are going to observe, actually it is coming to the activity from 1923 onwards. Okay. And Bronsted and Lowry, two scientists, actually they have clubbed their concepts here. According to this theory, acid is a substance that is capable of donating a proton. Okay. So Arrhenius has defined acid and base in terms of the H plus ions, and OH minus ions. H plus ions are also nothing but a proton. Here also Bronsted-Lowry, what they have told, acid is a substance capable of donating the proton. That means in case of the acid both are same, and bases are substances capable of accepting the proton. Okay, here only these two theories have been differed. Okay, so acids are proton donors and bases are the proton acceptors. So this is a difference. And if you see the example like ammonia in presence of the water, so here ammonia it is going to act as base and water it is going to act as acid, thereby what it is going to produce? Ammonium ion. Okay, so this ammonium ion plus OH minus ion, thereby this ammonium ion it is going to be called as conjugate acid, and OH minus ions it is going to be called as conjugate base. Okay, so this Bronsted-Lowry theory has raised the point of conjugate acid and conjugate base. In this one more example, if you see in case of the acid, that is acetic acid if you take, and in the water it is going to act as a base, then it is going to produce CH3COO minus, which is going to be called as conjugate base, and hydronium ion H3O plus it is going to produce, it is called as conjugate acid. Okay, so a conjugate base, that means according to the Bronsted-Lowry concept, a conjugate base is an ion or molecule, which is an ion or molecule left after an acid donates a proton. Okay, acid means donating a proton, H plus ions. So a conjugate base is an ion or molecule that is left after a donation of the proton it is going to take place, whereas conjugate acid is an ion formed after accepting the proton. Okay, so that is the difference here. So the pairs of the substances which are formed from one another by the loss of proton or gain of proton, which are called as conjugated acids or conjugated base pairs. Okay, but this theory is also having some limitations. So what are the limitations? Like the substance like BF3 and aluminum chloride AlCl3. So these are also do not have any hydrogen and hence cannot give a proton. Okay, so these compounds cannot donate a proton, thereby they are going to act as acids. How they have acting as, how they are going to act as acids even though they do not donate the proton. So this theory is unable to explain the reason behind it. So that's why some of the limitations and drawbacks are also observed in this, and thereby afterwards we have seen the another concept, that is Lewis concept. So in 1938 we have come across the concept that is framed by the scientist Lewis. Okay, in 1938 this theory, according to this concept, an acid is a substance which accepts a pair of electron and base is a substance which donates a pair of electron. So according to Arrhenius and Bronsted-Lowry theories, the acid is a proton donor. Okay, in terms of the hydrogen ions they have explained. But coming to the Lewis concept, Lewis has explained in terms of the electrons. Okay, so an acid is a substance which accepts the pair of electrons, whereas base is a substance which donate the pair of electrons. Okay, so donate a proton, it is an acid, but here accepting the pair of electron it is going to be called it as an acid, whereas donates a pair of electron it is going to be called as base. But this theory is also going to have some limitations. Let us see what are the limitations. The relative strength of acids and bases cannot be explained by this theory. Any type of the acid and base, it is going to have some strength. So the relative strength of acid bases means actually the strength of an acid depends upon its tendency to provide the proton, or more precisely hydroxynium ion in the solution form, right? So whenever they are produced in the solution form, the strength of an acid generally depends upon the capacity or tendency to provide the proton or a hydroxynium ion in the solution form. So strong acid refers to that the equilibrium lies very much to the right hand side of the reaction. That means whenever this HCl, whenever this is going to be called as strong acid, so in presence of the solution, it is going to provide the hydronium ion H3O plus Cl minus ions, right? So thereby you can say that always the backward reaction takes place almost to the negligible. So, this only the forward reaction every time it is going to take place, but this backward reaction the process it is going to be very negligible, it is going to be there, because this is a very strong acid. And weak acid, so whenever we are going to take the weak acid, it refers to that equilibrium lies very much to the left hand side and dissociation of acid to give H plus or H3O plus is very small. That means whenever we will take the weak acid like CH3COOH, acetic acid, okay. So in case of this acetic acid, if you take in water, it is going to produce CH3COO minus, right, plus H3O plus hydronium ions you are going to see. So thereby in case of the strong acid and in case of the weak acid, the strength of the acid it is not going to be defined, because the forward reaction and the backward reaction. So when it is going to be in the equilibrium state. So this theory is unable to define what is the weak acid, what is a strong acid, okay. So that's why these three theories of the acid and bases are going to give you some of the information only relative to the what can be called as acid, what can be called as base, but with some of the limitations are there for each and every theory, okay. Hope you have understood the difference between Arrhenius theory, Bronsted-Lowry theory and Lewis theory. Thank you for listening.